The agenda for this video would be to understand what are classes and objects in Python, and in the second part of this video we will see about what inheritance is all about in Python. Okay, so till now we have worked with functions and variables, but real world programming is not just about storing values, it is about representing real world things. Now let me ask you a question. So, in our day to day life, what are the things which exist or we see around us? So, it could be a car, a phone, an ATM machine, a laptop, mobile, all of this, right? So, each of these things has two things, it has characteristics, and second is the behavior. So, speaking in terms of technicality, characteristics represents data and behavior represents action. Hence, in programming, we represent these using classes and object. Okay. So a class is a blueprint or template to create objects. So this is the basic and technical definition of a class. Now, if we talk about the definition of an object, so an object is a real instance of that class. So if you have worked with any other programming languages which support object oriented programming, such as Java, so there also you might have heard about the concept of class and object. So it's more or less the same over here as well in Python. So let me give you another example. Let's say if we talk about a real world example. So let's say there's this car design, right? So a car design can be of let's say Creta, Hyundai i10, or Maruti Brezza. So all of this will be fall under the category of car design. Now let's say you own a car from Maruti Brezza. So that actual car will represent as an object, and car design will be represented as class. Now if we take another example, let's say mobile model. Let's talk about iPhone 17. So that will be representing a class, right? And if you own any iPhone 17, then that will be an object which represents to iPhone 17 class, right? So class defines an object exists. Now, if I clear this out, let me first. If I say class, it defines what a student is. And if we talk about object, so that represent an actual student. So let's consider an example where there's a class which has n number of student. So consider a class of 10th grade, right? So what it will define? So it will define that the all the students which are studying here are of 10th grade. Now if we talk about object, so let's pick any one student from that 10th grade class, so that student will represent the object. Okay, so enough of this theory part. So let's move from theory to some hands-on coding, then you will get some more understanding about it. Let me clear this out. Let's define a class called as student. Okay, and in here we'll say pass. So what pass is we already know. Okay, for a quick revision, we apply pass where we want to create any kind of placeholder. Okay, so let me make this cs small. Now it's all good. And here below pass, let me create an object called as obj. If I try and print this object, so Let me run this file once. So see here it says main student object at the some value they have given. So let me explain this to you. Uh, there's this class keyword involved, okay, and the name of the class is student, and obj stands for object. So while running this file, did our file crashed or this program got crashed? No, right? So meaning class is real now, right? Now let's add some attributes to this class. Okay, so initially we have given pass over here. So now let's add attributes. So first attribute would be, let's define a variable called as name and assign its value as Rahul, and let's define another variable called as age and give its value as, let's say, 21. Now what we will do, we will create an object. So uh, let's this be the object of the class obj, and now this time we will try and print using object name obj dot name. Okay, and in the second line let's print the attribute value of age. So let's print age. Okay, so if you look at this particular section of code, right? So this name and age, these are called as the class attributes, and they are stored inside class, and they are accessible by the object. So here we have created an object, and using this object name along with a dot operator, we are able to access both these attributes, right? Now if I run this file, what it will do, it will simply print the value. Okay, let me create another student, say class student 2. Okay, and this time let's give the name as, let's give Pawan, and let's define the age attribute and give its value as 22. Okay, now for that, if or else let's give this attribute name as name1 and age1. So using this same object, we cannot call these name1 and name2. So see, if I put a dot operator, it will still shows age and name for the previous ones. Okay, so for that you have to create another object called as obj1, and let's give the class name as student2. And this time, if I use this name object name as obj1 along with a dot operator, we'll get all these attributes which are defined under this class called as student2. So let's take this as age1 over here. And now if we run this file, what will the output? So it has printed age1, which is 22, and here with the previous object name we are calling age, which has value 21, and it has printed the same. Okay, now coming to the next part, so let's talk about constructors and instance variable. Okay, now what is constructor? So in our previous videos we have seen this particular thing which says underscore init underscore followed by small brackets. So this is a special function that runs automatically when object is created. Okay, you will get to know more about it once we have this demo example. Okay, so let me clear this all out and let me create another class student, and let's create this function. Okay, And over here, let's put this statement. I'll explain all this at the end once I write this whole code. Okay. Okay. And over here, let's define another attribute called as age, and let's call that as well. Okay. Now let's create two objects. One is s1, and we'll call this class name and give the parameters as James, and so name would be James and age is, let's say, 25. Okay. And another object s2 with name as, again, class name, and this time let's give name as Jim and age 30. So if I do a print s1, we'll call this first object name dot, and put name over here, and secondly, again using the first object name, let's print age. Okay. And again let's do a print. Here we'll call the second object name and do the same thing. So before running this file, let me explain each and every step. So here's self. So what does the self mean? So self refers to current object, and each object stores its own data, right? So there will be a separate memory also allocated to it. And now we can create unlimited students, right? So as we have created two students over here with name James and Jim, and their ages are 25 and 30 respectively. So if I run this file, so see, it has printed about the name and ages of those two students. So if I ask you a question like, which one is more flexible, hard coded variables or constructors, right? So we have worked with variables also, assigning their values or hard coding them. And now in this example, we are doing the same thing using constructor. So both these example, if we compare, then we can say that constructors are more flexible. Okay. Now let's go to the further section of this video and talk about methods. Okay. So objects should not only store data, they should also perform actions, and that can be done using methods. So what will be the technical definition of method? So a method is a function inside a class. Let's explain this with another demo example. So let me clear up till here. Okay. And now we will use this self again to call name, and let's do that again for age. Okay. And let's create this function called as def, and function name as say underscore hello, which will have this self current object. And then we will do a print which will say hello plus self dot name. Okay. And in the next line, let's print my age, then we'll put plus over here. Okay. Here we are changing the uh, integer type to string. Okay. So that both the strings can concatenate. And now let's create an object called as s1, and here we'll call the class name and put this name as, this time let's put Tim. Okay. And then we'll call this object name And using this object name, we'll call this function say hello. Okay. So let me clear these indentations errors. Okay. Now here what we have done, we have created a method basically with name say hello, and this method belongs to this particular class. And to call this method in order to execute it, we are using the object name, right? So here we have created the object for this class and given the values as Tim for name and 25 for age. And at the end, we are calling this function using this object name. Okay. So if I run this file, so it has printed hello Tim and my age is 25, right? So let me ask you a question. So what do you think will print if the name changes, right? So let's print over here as Neha. And if I run this again, so this time it has printed hello Neha and my age is 25. So that's what we call as an interactive learning, right? So coming further to the next topic of this video, which is class versus instance variable. Okay. So I'll give you a quick explanation. Okay. So let me clear this out first. So let's say if a type is instance variable, then this belongs to a specific object, and the example use would be name, age, etc. Okay. Now let's say if the type is class variable, so it will belong, or I can say like this, it belongs to means it is shared by all. And example would be college, school, team, etc. Okay. So uh, so basically instance variable that belongs to a specific object. An example would be name, age, right? And if I talk about class variable, so that will be shared by all, and example would be college, school, or team, right? So let me clear this out with a demo example. So let me again create a class named as student. Okay. And over here, let's have this variable called as college and assign its value as ABC University, right? College equals to ABC University, as this belongs to class, so this will be considered as a class variable. Okay. Now again, let's have this function. This time let's keep only one variable, which is name. Okay. And let's call this name using the statement self dot name equals to name. So this will be the instance variable. I'll write it over here. And then let's create two objects. S1 is equals to student, and put the name over here as Rahul. And let's create another object for another student whose name will be, let's say, Priya. Okay. Now it's the time to print them. So we'll use S1 object name to call name. Okay. and then we'll use again this s1 object to call college. In the second line, let's do the same thing using second object s2. We are calling name and college. Okay, so before that, let me run this file. So see, it has printed the name of first student as Rahul, who belongs to ABC University, and second student Priya, who again belongs to ABC University. Now, what if I change college for S1? Will it affect S2? So let's try and do that. So here, let's do this print, and let's say before name change. And now here what we are doing, we are changing the college name of S1. So we will call this object name S1 dot, and we'll use this college attribute, and here we will say XYZ University. Okay, now let's say if we print again after name change, okay, if we print these two values again, let's copy and paste it directly over here. Let's see what would be the output. So see, before name change, it was ABC University for both Rahul and Priya. Now after name change, Rahul University has been changed to XYZ University. However, Priya's university is still ABC University. So that was all about the class variable and instance variable. Now coming to our next section of this video, let's talk about what are inheritance in Python. Okay. So have you ever wondered why we don't build everything from scratch in programming? So just like in real life, children inherit features from parents. In Python too, classes can inherit properties and behaviors from other classes. And so this feature is called as inheritance. Now, if we go by the technical definition, inheritance allows a class to use the attributes and methods of another class without rewriting the code. Hence, it solves the purpose of code reusability. It helps in less duplication of code, and also it helps in easier maintenance, and at the end it totally contribute towards the professional programming. Now let me clear this out with an example, and before that let me tell you the syntax of it. So let's say if you create a class with a name parent, so if you want to inherit this class into a child class, so let's say you create another class with name as child. So if you want to inherit this parent class, so within the small brackets, you just need to provide the name of your parent class. So this is basically the syntax of inheritance. And just like a real life, a child gets properties of parent automatically. And so in case of inheritance, whatever functions or attributes parent class has, all those will get inherited by the child class. So let's begin with a demo example. For that, let me create a class with a class name as animal. Okay. And let's create a function also under this class having name as speak. So here we will print the statement called as animal makes a sound. Now let's create another class. So this will be acting as a child class. Let's name this as dog. And to inherit this particular function into this child class, we will provide the parent class name within this small brackets. Now let's have it this pass over here, as we don't need to write any code for this. We are just trying and implement this function into this child class. Okay, so for that, let's create a object called as d, and here we'll provide the class name of the child class. So this will be the child class object. Now using this child class object, we will be able to call the functions present in the parent class. So we'll just write t and followed by a dot operator. We'll use this function which is defined in the parent class, right? Now if I run this file, see, it has printed animal make sound. So this explains that the child class dog haven't had this function speak defined inside it, and still it can use it. So this is called as inheritance. Now, did we wrote the code twice? No, right? So this solves the purpose of code reusability. Now, this was one such example. Now, in the same example, let's add a function to this child class as well. So let's define a function with a name as bark. Okay, and in here we'll do a print statement again, and inside it let's write this dog makes a bark. Okay, now again we'll create this child class object. So we will call this parent class function with this child class object, and even the function which is written inside this child class can also be called using this child class object. Okay, so if I run this, now I have this two statement getting printed, which is animal makes a sound and dog makes a bark. Okay, so now child class can do everything parent can, plus its own extra features. So whatever functions parent class has, along with that, whatever functions child class have, so this child class is capable of doing both of this together. Okay, okay, now let's discuss about this concept called as method overriding. So sometimes what happens, child doesn't likes parent behavior and says I'll do it my way. So this is called as overriding. Okay, so let's explain this as well with an example. Now in our previous example we have defined this function called as speak inside the parent class animal, and there was this different function called as bark inside this child class element. What if I create this same parent class function over here as well and name it as speak? Okay, so in here we have the function having the same name for both child as well as parent class, right? Now what will happen, inside this parent class we have defined this print statement which says animal makes a sound, but inside this child class function which is speak again, we have printed this statement, dog makes a bark. Now what would be the output? So let's try and run. Now this time only one statement got printed, which is dog makes a bark. Because what happened, whatever was initially performed under this speak function for the parent class, we have changed its uh, implementation inside the child class. Means we have changed the print statement basically, and this time it has printed only what is there inside the child class. So this the whole concept is called as a method overriding. So child replaces parent method, and Python always prefers child version. Okay. Now there's this another concept of multi-level and multiple inheritance. Okay. So let me explain this with an example. So we have seen a parent, then a child. Okay. So whatever properties parent have, automatically child inherit those properties. Now let's say child has another child of his own, which will be the grandchild of the parent. So now whatever property this parent is having and whatever property this child is having, so all of these property will be inherited by the grandchild. Okay, so let's discuss this with our demo example. This time we are creating a class. Let's name it as grandfather, so it will be more clear to relate. Okay, and in here we are defining a function called as property. Okay, and inside property, let's do a print saying grandfather's property. Now let's create another class called as father, and here we are trying to inherit grandfather class. Okay, so we'll put this parent class name over here, and let's create another function. This time let's name it as car. Okay, yeah, so here let's print father's car. Okay, now let's create another class which is, let's say, called as son, and in here let's inherit this father class over here. Inside, let's define another function. This time say it's bike, and print son's bike. Okay, now for that let's create an object of this son class with s as the object name, and here let's try and im- let's try and call this car function which is defined under this father's class, and this bike function which is there inside this son class itself, and let's call the function which is present under the grandfather class, which is property. So if I run this file, what I'll see, all the three statements getting printed over here, which is father's car, son's bike. Okay, this, let me correct the spelling. This is grandfather's property. So see, all the three statements has been printed. So that means properties pass through generations, just like in real life. Here in programming also, the properties pass through generations. So with this son class, we were able to get or inherit whatever functions was present in the grandfather class as well as father class. So this is called as multi-level inheritance. Okay. Now there's this another concept of multiple inheritance. Okay, so which means that here child will inherit from two parents. Okay, so let's get this cleared with an example. Now this time let's create a class called as father. Okay, and here let's define a function called as car, and let's do a print which says car from father. Again, let's create another class. This time let's say its name is mother, and here we are defining a function called as house, And here let's print house from mother. Okay. And now is the time to create son class. Here we will be doing what we'll be doing here. We are inheriting from both father and mother class, so you can put the respective name. So let's do it like this. We'll put here father as well as mother. Okay. Now here let's give nothing, simple pass. Now let's create an object of son class with an object name as s. And let's try and call one function from father class, the other function from mother class. So if I try running this file, so see, both the statements got printed. So the son got car from father and house from mother. So this is called as multiple inheritance, means a son or a child class can inherit from two parents also. Okay. And also Python supports multiple inheritance, and it's a powerful concept, but you must use it wisely. More we'll get once we start working with some automations. Okay. Now there's this another concept of super. So what happens, sometimes child wants its own version plus parents behavior. So for that we use super. Let's explain this also with an example. Now this time let's create a class called as animal, and again create a function called as speak and print animal speak. Okay. Again we will be creating another class called as cat. Now this will inherit this parent class animal. Okay. And let's create another function called as speak, having the same name of the top present in the parent class. Now here we will use super, which is written like this. And using super along with dot operator, we are calling the speak over here from the parent class. And then let's do a print cat speaks. Okay, this we are going to print under this function. Now in order to call this function speak, we need to create the child class object. So let's do that. C is equals to cat. Okay. So we have created this child class object having name as C. And now using this C and a dot operator, we are calling this function speak. Okay. So now let's run this file and see what happens. Okay. So here we have the output as animal speaks, which is coming, which has written under the speak function for the parent class. And we have this statement called as cat speaks, which is coming from here. Now, if you look closely under this child class, we have created this function called as speak, right? And after that, using super, we are calling this function from the parent class. Okay. So, and after that, we are printing cat speaks. So, what happens? Super calls parent methods before and after the child logic. So, here, super is calling the parent method speak, and it is printing whatever is written under this print statement, which is animal speaks. And after that, this particular line is getting printed. So this is the whole purpose of using super in order to call the parent methods before and after, before or after the child logic. So with that, we have covered the agenda for this video, which was the classes and objects in Python, and also we have seen how inheritance works. So we will conclude this video now, and I would like to add this point as well. Like, inheritance allow us to reuse code, reduce duplication, and build professional scalable application. Okay.